Okay, hello, good evening, guys. All right, welcome back to our June week 3. All right, the third week of June. So, where's everyone? Why is there only 6 of you? All right, everyone is late as usual. All right, anyway, so welcome. Hello to you guys. Today we are going to finish our chapter 4 because the cats died. What cats? You mean the cats last week? No lah, it's just a very funny background. I just decided to put it lah. My background has no reason one lah. Okay, anyway, so today we are going to finish this chapter 4. All right, so as you still remember, what have we learned last week? We have learned about this good-looking chart. Okay, the kalau nak kawin chart. Okay, can understand? Do you still remember? All right, so let me just quickly repeat this thing. Okay, you have this thing called kalau nak kawin mesti ada zakat fantastic supaya perkahwinan Jun dan aman. All right, so the taller they are, the better looking they are, the more leng zai they are. So the more likely they will take the wife from the lower person. Right, so remember that, right? And of course you have CH. Okay, being Qinghua, there's a Z in between him. Okay, you still remember this, and of course, example, so zinc oxide, the oxygen is married to zinc, and carbon is more leng zai than zinc, better looking than zinc, so carbon can take the oxygen away. All right, so now zinc is dumped. He's dumped alone. And then, of course, you have aluminum oxide and carbon. Nothing is going to happen because aluminum is better looking than carbon. So carbon cannot take the wife away. All right, so all these are just, things that you have learned last week. All right, I'm not gonna, repeat too much already lah. Okay, yes, Rebecca, hello, good evening. All right, so we will be using the same thing today. All right, let's look at 4.3. Okay, today's lesson will be almost the same as last week. All right, it will be the same as last week. We will be mainly talking about this reactivity series. Okay, the good looking chart. All right, so same thing. Kalau nak kawin mesti ada zakat fantastic supaya perkahwinan Jun dan aman. So this Mercury, it's not our matter. All right, so what is this? Okay, as you know, our focus is carbon. Okay, I want you to focus on the carbon. Okay, focus on carbon. Okay, why focus on carbon? Because carbon is our main character today. All right, carbon is the main character. All right, so as you know, carbon is taller than all these elements, right? Okay, carbon is better looking. Carbon is taller, more leng zai than all these, right? Zinc, okay, hydrogen, okay, no lah, zinc, iron, tin, lead, copper, and of course so on. Right, that means carbon can take all their oxygen away. This is last week's stuff. This is last week's stuff. That means if I am zinc oxide, okay, I have a wife oxygen, carbon will take the oxygen away because carbon is better looking than zinc. Carbon can take the oxygen from iron, can take it from tin, can take it from lead, can take it from copper. That means all these wives, they can be rampas by carbon. Of course, carbon is better looking. Carbon is more kacak, more leng zai. He can take away their wife. All right. So as you know from the first lesson we learned about this chapter, most ores we get it from the ground. Okay, you should remember Minecraft. All right. So most of the things you get from the ground, they are ores. All right, like your iron ore, and of course iron ore is iron oxide. All right, you have tin ore, aluminium ore, lead ore. That means everything of them they exist in the form of oxide. All right, that means I cannot use them straight. Right, for example, iron. If I get iron from the ground, it looks like this. Okay, it will look like this. So can you use them straight? Can you use this to build your car? Your car is made from iron. Can you use this straight? No, you can't, because it is the impure form. Okay, there's an oxygen in it, so you have to throw this oxygen away. All right, so how do you do it? You use carbon. You will use carbon, as you can see here. So if you get iron oxide from the ground, you will take carbon and put there and use carbon and rampas the wife away, and now you have pure iron. Simple, right? Simple, right? But here's the thing. If you go up there, you see, then so how about all these five left? All these five they exist in oxide too. Aluminium oxide, magnesium oxide, calcium oxide, potassium oxide, sodium oxide. All these are. So carbon, you see, that's the problem. Carbon cannot take their wives away. Why? Because carbon is not as good looking as these five guys. You see, these five guys are like the best looking guys. Very lengthy, very good looking, very tall. Because the taller someone is, the better looking they are, right? So they are very tall. That means carbon cannot take the oxygen away. Cannot take the oxygen away because carbon is shorter than them. So you might say, sir, why are we using carbon then? Why is carbon the main character? Why not we just use potassium, right? Why not we just use potassium and we rampas all these wives away? That will make this problem so much simpler, isn't it? Right? Why choose the middle guy when I can choose the top guy and take all their wives away? It will make sense, right? It will make sense, right? But why carbon? Why carbon? All right, let's look at this thing. Okay, this thing is an industry, right? The process of getting iron, the process of extracting iron is a business, all right? It's an industry, it's a business. So what's the main point in a business? What's the main point in an industry? Let's say you're running a business. What's the most important thing for you? It's about money, right? Right? Because if you're, I don't care whether you're a small company or you're a big company, at the end of the day, a business job is to earn money, right? Yes, potassium is more expensive. Yes, again, Yashwini, you got it. So potassium, it will make no economical sense. So why carbon? Why carbon? Because carbon, among all these, carbon is the cheapest. Cheapest like dirt cheap, because it is actually dirt, right? Have you seen something called Coke? Okay, not that Coca-Cola Coke, right? Coke is actually a fuel. This thing is actually your carbon. All right, as you can see, they are like charcoal. All right, they are black and there's plenty of them. This is cheap, like dirt cheap. This is dirt, right? So this is why we use carbon. So it will make a lot of sense if you use carbon to extract these things instead of using potassium. It will cost too much money. All right, so because like I said, at the end of the day, a business purpose is to earn money. All right, so how do you do so? How do you earn money? You reduce your cost as much as possible. Okay, you reduce the cost and you increase the earnings. Okay, wow, I'm teaching economy now, isn't it? All right, so let me just talk a little bit about manufacturing. Guys, do you know the top manufacturers in the world, they actually earn a lot of money. Their profit margin is very big. Okay, what do I mean? All right, let's take for example Nike. Nike, you all wear Nike shoes, isn't it? I'm sure your sports shoes they are either Adidas or Nike, right? Right. So I believe most of y'all wear Nike because that's the most common shoe to wear. All right. So the meta. Oh, what do you mean? Is that a shoe or are you referring to the metaverse? All right. So let's talk about Nike. All right, Nike is one of the biggest sport apparel company in the world. Okay, so let's talk about a shoe. Do you know how much? It's a shoe, is it? All right. So do you know how much does it cost for Nike to make one pair of shoes? You want to take a guess? By the way, most Nike shoes, they're either made in Vietnam or China. That's where the labor cost is very low. All right. So to make one pair of shoe, okay, Nike produces a lot of shoe. Okay, either it's a Jordan 1 or an Air Force 1 or a Cortez or whatever. So for Nike to make one pair of shoe in China, including the material, the labor, the shipping and everything, every pair of shoe will cost them around 15 USD to make. So how much is 15 USD? If you do the conversion, 4 point something, that's roughly around 60 something to 70 for a pair of shoe. All right. So can you see how much the profit is? How much is a pair of Nike shoe? Guys, do you wear Nike shoe? If you walk into a shop today, let's say there's an offer. Okay, there's a year-end sale or whatever. How much is one pair of shoe? Maybe 200 to 300, right? And you think, wow, that's the deal of a lifetime, man. Because got usually year-end sale, or you go to like those brands outlet in Genting, you see, wow, 200-300, that's so cheap. Hey, they are still earning. Hey, you imagine 60 bucks per pair of shoe. If they sell for 300, they're still earning 5 times. They're still earning 5 times. As long as they sell it above 100, they are still earning. It's just that they earn less. So you see, don't believe in that bullshit. They say, oh, when Nike is doing sales, they are actually losing money. What kind of business actually wants to lose money? So it will make no sense. Okay, Nike Dior is so much profit. Yeah, I agree. Hey, that's like one of my dream shoe, man. Okay, that shoe is currently 40,000. Guys, do you know what is Nike Dior? Okay, Nike collab with Dior to make a pair of Jordan 1 Nike Dior. Wow, that's like my dream shoe, man. Hey, that pair of shoe is like what, 40,000 currently lah. Currently 40,000 lah. So if you use some common sense okay lah, the one maybe not 50 lah, maybe it costs like a little bit more, maybe a few hundred to make. Hey, that pair of shoe when it's released is 8,000, you know. Okay, now the resale price is roughly around 40K. Imagine you are wearing a pair of Asia on your feet. You know Prada Asia? It's a freaking car. Your shoe costs as much as a car. So you do the math. All right, no freaking sense. Okay, another example is actually Apple. Okay, another example is actually Apple. All right, so do you know how much does it? Let's just talk about the latest iPhone. All right, if let's say you were to buy I don't know, iPhone 13 Pro Max, Max Pro, Pro Max, whatever lah, the biggest spec one lah. Okay, yes, Savannah and Martin, hello. Didn't see you guys there. Okay, anyway, so we are in this thing. It's actually from last week. Okay, from last week. So I was talking about industry current. Okay, just now. So as I mentioned, okay, if you get iPhone 13 Max Pro, whatever lah, okay, whatever it is. Okay, I'm not an Apple fan, so I don't know. So you know how much does it take for Apple to make one phone? An iPhone 13? Estimated cost for the material and workmanship, an iPhone will cost you around $250 US. Around that, $250 US. So if you do the math and you do the conversion, one iPhone will cost around 1,000 something ringgit for Apple to make. 1,000 plus, okay, maybe 1,001. Okay, let's just say it's 1,001, okay? 1,001 to make an iPhone 13. So how much are they selling you? Guys, have you checked the price of the latest iPhone? If I'm not mistaken, it's at least like 5K, right? I mean, it makes no sense lah. I wouldn't spend 5K on a freaking phone, okay? My laptop is like 3K. Why would I spend more on a smaller device? Right? And they sell the charges separately, exactly. So let's just say their cost is 1,000. To make everything simple, let's just say 1,000. So if they sell it for 5,000, they are making 5 times the profit. All right. So like I said, at the end of the day, a business job is to earn money. They don't answer to the consumers, they answer to the shareholders. All right. Yeah, and it goes viral. Yeah, exactly. So it will make no sense. That's why when it comes to extraction, why don't we just use potassium and take all these wives away to extract these things? Why are we using carbon? Because carbon is the cheapest. It makes the most sense. All right. So for those who just came in, this is actually from last week. The Kalau, Nakawin, Mesti, others, Zaka, Fantastic, Supaya, Pekawinan, Chun, and Aman. Okay, this is from last week. And then usually when we extract all the bottom stuff, we will use carbon. Right? We will use carbon. Then what about the upper stuff? What about all these upper stuff? All these upper stuff, since they cannot use carbon, right? That's another method of extracting them. Because you see, carbon cannot take their wives away. Carbon is not as good looking as them. So carbon cannot take their wives away. So what do they do? How do you extract these? Like you see, aluminium is very important. You use aluminium to make soft drink cans or whatever. So how do you extract these things? You will use something called electrolysis. All right, electrolysis. So what is electrolysis? I'm sure you learned this in Form 2, right? If you still remember, that is okay, electrolysis. What is this? Electrolysis is this thing lah, when you have a battery. Okay, this battery they are connected to two metal rod. Remember this thing? That means I use electricity to separate them. This was in Form 2. When you separate your water, right? Water is H2O, right? H will be attracted to negative, O will be attracted to positive. So if I use positive and negative to break them, that is electrolysis. So same thing. How do we break aluminium and oxygen away? Aluminium will be attracted to the negative, oxygen will be attracted to the positive. So I just break it. Okay, which is anode and cathode. Yeah, the anode and cathode thing. Okay. Siva Shite. Hi Siva. Have I seen you before? Were you in my class? Okay, okay, which branch are you from? Oh, you're trial. Okay, which branch are you from? Okay, anyway, so this is your anode. This is your cathode lah. Okay, anode is the positive, and then cathode is the negative. Oh, good company. Okay, sure. Oh, that means you're from my branch. Right. Anyway, so these things we have to use electrolysis. Okay, we have to use electrolysis. Then all these things are very simple. I just use carbon, I can run past their wife away. I just use carbon, I can run past their wife away. So this run past wife process, please don't write like this in exam. Oh, because carbon can run past the wife of please don't write like that. The run past wife process is called reduction. Okay, in BM it's called penurunan. So this process is the Rampas wife process. Okay, that's how I memorize lah. Okay, so as I said, this one I already told you how to memorize last week. So if you were not here last week, let me repeat this again. Okay, you can actually write this down. Right, so you have kalau. I just memorized the symbol kalau, nak kawin, mesti ada, Zaka, Fantastic, Supaya, Perkawinan, Chun, dan Aman. All right, so you just want to make any story you want. Okay, but it helped me. Wow, Martin, you see, oh, you had a quiz, is it? You had a quiz. You see, this is what we call smart studying. Hey, how do you think I get straight A's in SPM? Hey, let me tell you this. I'm not trying to show off. But when I was in Form 4, I basically slept through the whole year. I was not paying attention. I was not listening. I did not take any tuition class. I basically flung my whole Form 4. And then when I was in Form 5, when Form 5 came, SPM came, right? SPM is around the corner, right? So I was like, never mind, we chill a bit first lah. And then when March came, suddenly it hit me already. Oh shit, I should start studying. And then at around March or April, I think it was not that early, maybe May or June, I started studying. Hey, you imagine in that short 4 to 5 months, I have to cram 2 years worth of stuff into my brain. And I take 11 subjects. You think I do it for, you think I just do it like that? Okay, so this is called smart studying, guys. Hey, I have a lot of ways to memorize stuff like this one. This is called lazy studying. Because I'm a person who hate memorizing stuff. All right, so hey, in 2 months, I settled sejarah, you know, Form 4 and Form 5, I memorized everything into my head. Okay, so unless it's perverted, yeah, the more perverted they are, the more hams up they are, the more you memorize them. That's how our brain works. Okay, anyway, so this is how it works. Anything lower than carbon, you can use carbon and rampas their wife away. Anything higher than carbon, you have to use electrolysis. That's all. That's all. This is from last week's stuff, right? This is from last week. This is from last week. So I'm just applying it now, you know, this week. So it's basically the same thing, right? So how do you do this actually? How do you extract iron? Okay, let's talk about iron ore. Of all the ores, why are we extracting iron? Because iron is the most useful. Okay, iron is the most useful. Hey, iron is used everywhere. Yes, Nicholas, hello. All right, so iron is used everywhere. Do you know where you use iron in? You use iron in construction. All right, you use iron in making cars. Your car body frame is made from iron. Your car parts, the engine, okay, they are, well, sometimes they're made from aluminium, but most of the time they're made from iron. So you see, iron has a lot of use. All right, and it's mostly in the main scale use. Okay, they are used in the large scale. So this is why we care about iron ore. So iron ore is also called iron oxide, right? Oh yeah, by the way, for those who played Minecraft, this thing is called blast furnace. Right? I know, it's Minecraft. I know. Okay, so blast furnace in BM is called Relau Bagas. Okay, Relau Bagas. So this is blast furnace. Okay, basically it's a big ass pot. It's a big ass pot to cook things. So what are we cooking? We are cooking iron oxide. Okay, we are cooking iron oxide. So how do you use this? The material, the raw material is inserted here. So you put your raw material from the top, and as they go down, they will start to burn and burn and burn and burn and burn, and then they will melt. Hey, you know how hot is this thing? You know how hot is this blast furnace? This thing is around 1600 degrees. Okay, so you know why I say this thing makes no sense? Okay, when you play Minecraft, I have a student tell me, wow, sir, in Minecraft, I have like 8 of these in my house. Do you have something so hot in your house that you have a whole room? Good for you, Yashwini. Okay, good for you. All right, so guys, you wouldn't fit this thing in your house because this thing is like a freaking condo. Okay, it's like a freaking condo. You see how many stories is this? You can put like 5 in your house. Where do you live in? Do you live in a even a castle wouldn't fit? What the hell? Okay, anyway, so this is a blast furnace. Okay, what's the function of blast furnace? Okay, so Ivan, that's a good question. Blast furnace is to extract iron ore. Okay, is to extract iron ore. Remember just now the rampas wife process? I said carbon can rampas the wife of iron, right? So now you have iron alone, right? The point now is to get rid of this oxide, to get pure iron. So how do we do it? How we put it at the top. So what are the raw materials? You put in, of course, number 1, your iron oxide. You put in the iron ore. You put in the iron ore. Second, you put coke. Coke is the carbon. Coke is the carbon. Not your Coca-Cola. So as you can see, the carbon. So what will this carbon do? This carbon will run past the oxygen away. When they run past this oxygen away, now you have pure iron. You now have pure iron to be used in whatever you want to use, okay? Your construction, your cars, and whatnot. So the third thing, you actually need a third thing. You might say, sir, these 2 things is enough, right? Yes, it is. But usually we will add one more thing, which is called limestone. Okay, limestone. You might say, why add limestone, Lester? Because you see, this limestone, it actually makes this reaction faster. All right, if I don't use limestone, this thing can still happen. Carbon can still take the oxygen away, which is still okay. But since now I want to make this reaction faster, I'm doing business, remember? I'm doing business. I'm doing an industry to earn money. So my job is to make the thing as fast as possible. That's why I add limestone. All right. Remember I told you what is limestone? What is limestone? Your Batu Cave is limestone. Okay, Batu Cave is a big ass limestone. Okay, so that's the limestone lah. So you just put the limestone in. So what's gonna happen? All these rubbish point, you don't need to know. You just need to focus here. You just need to focus here. As you can see, iron oxide, oxygen is married to iron, right? And carbon is better looking, right? Carbon is taller, right? From the up there just now, carbon is taller than iron. So what will happen? Carbon will rampas the wife away. So now you have iron left and you have carbon dioxide. See, carbon got the wife already. Carbon rampas the wife already, and then the carbon dioxide will go away. Now you have pure iron. This is how we extract iron. And then the next two you might say, so I got carbon monoxide one. This thing helps too. So you have carbon monoxide. Carbon monoxide also rampas the wife. And then you have carbon dioxide and iron also. So the main thing is to get iron. Our main point is to get iron. When will we learn the Roman numbers? Okay. Yashwini, if you really want to know, okay, you might say, sir, why got 2 and 3 here one? Why got 2 and 3 here one? Because iron has 2 oxidation numbers. So what is it? What does it even mean? This is in chemistry. Iron, they exist in the form of iron 2 plus and iron 3 plus. So this thing is iron 2 and this thing is iron 3. Makes no sense, isn't it? Okay. Hey, if you want me to explain about this thing, I can go 1 hour, you know, because iron has something called shells, and in the shells you have subshells. Okay, so iron has 4 subshells. They have 1s, 2s, 2p, and okay, you see? What the hell is this? This is college chemistry. Okay, so when I say it's hard, it's really bloody hard. How do you think I went through college? All right, hey, let me tell you something. When you go college, okay, from your head now, you must be thinking, wow, sir, next year if I take chemistry, it will be very hard, isn't it? I will say okay lah, because if you go college, when you study college chemistry, and you look back at SPM chemistry, that thing is like a freaking kindergarten level. Okay, college level is the shit. And then when you go to university and you look back at your college, you say, wow, how can I find that thing hard? University is so much harder. So can you see the level? Can you see the level? So you think university is easier? All right. Teachers keep Form 4, but okay. I mean, of course it's not fun, guys. If I were to do it again, I wouldn't sleep during Form 4. Do you know what? Do you know how an agony that was? Yeah, I know it's cool. I got straight A. Okay, fine. I studied in 4 months to get straight A. You know how torturing that 4 months is? You know what did I do? I actually cut off my internet. I cut off my internet. I asked my mom to keep my phone away, and I forced everyone in the family not to switch on the TV. I basically study 14 hours per day. Do you think that's fun? I mean, paran muka lah. Who asked me to sleep through Form 4? So I pay the price, lor. So you think it's fun? If I were to ask you to do it, I will ask you to do it the proper way. That means Form 4 you study, Form 5 you study. You go through the healthy way. My way, my method is the sacrificing liver method. You are basically torturing your liver and your brain, and I don't know, God knows what else. All right, so totally not worth it. Please don't do it. even your mental stress. You know, during that time studying for SPM, my whole face was full of pimple. I was so stressed out. Okay, I couldn't digest food well. I couldn't eat well. I couldn't sleep well. I was under this hell for like 4 or 5 months. Not fun. Okay, not fun. Please don't do it. Okay. Anyway, so okay, let's look at the bottom. Now this is where you get your pure iron. You see, when the iron is melted and sink to the bottom, this is where you get your pure iron, your molten iron. Okay, what does it mean by molten? Molten means leboran. That means melted iron. Is it hard? Well, I would be lying if I say it wasn't. All right. So this is your molten iron. Then they will pour it into the mold. This is the mold. You know, it's mold. Mold is the acuan lah. Basically, this is like making kueh. This is like making kueh. There's a peribahasa for it, lah. Bagaimana acuan begitulah kuehnya. Guys, is your BM still okay? So this is the acuan lah. So when they pour it into the acuan, okay, let's just say okay, this process is called smelting, by the way. Smelting. Hey, you learn smelting in Minecraft, didn't you? Okay. Yes, it's just like Minecraft. Yes, to make iron bar, There, isn't this like making kueh? They just pour it into the mold lah. That thing is the blast furnace. So they pour it out, they pour it into the acuan, then they get then you will get something called iron ingot. Oh, god damn it. God damn it, why is it Minecraft? Oh my god. Hey, they should be showing me this. Okay, why they should be showing me this? My goodness, why? Okay, in what matter, in what sense do I want to? Oh my god, Minecraft again. I don't know whether should I cry or should I laugh. Okay, anyway, so this is your iron ingot lah. So your iron ingot is like the raw, or some they call it raw steel. This is the raw steel. You just sell it to whoever they wants to buy from you lah. You can sell it to car manufacturers, to construction companies. Basically, they will use this to make whatever they want. Okay, to make this thing to car bodies, to make it into buildings or whatnot. So that's Minecraft, isn't it? Right. So anyway, can you see the top part here? Okay, take note here. Okay, there's a part called, you must say, sir, the iron is the important one. Why this one got one more thing called slag one? Take note of this slag. Slag in BM is called sanga. What is this thing for? Okay, remember just now we add limestone. One of the points is to make this thing, sanga, to make the slag. Slag's job is to be made into cement. Okay, cement. What is cement? Cement is used in construction. So can you see, when I extract iron, it's mostly construction stuff. Because I use iron in construction, I also use cement in construction. So if I'm a steel company, if my company makes steel, I usually will make cement also. I will usually make cement also because it's the same business. All right. So needless to say, guys, if you run this business at home, not at home, okay, what the hell? If you run this business as your family business, you should be freaking rich. All right, human bacon. All right, you should be freaking rich because, well, this is an industry and this is like a major scale of production. So, wow, that's a lot of money, isn't it? Okay, so anyway, this is it for our chapter lah. So all these bottom points here, you can just kind of, skip. No need to read lah, or just read for fun lah. So at the end of the day, this good-looking guy's chart, you still have to memorize. The kalau nak kawin one. So anything lower than carbon, we can use carbon to extract, and anything higher than carbon, we have to do electrolysis. Okay, this is basically an extension of last week. And of course, this mining issue here, I don't want to talk about this. Hey, remember first week we talked about this? Remember the bauxite mining in Kuantan? So that's the pollution lah. Hey guys, you have been This thing was in geography. Remember, soil erosion, hakisan tanah, destruction of habitat, pemusnahan habitat, okay, water pollution, air pollution, sound pollution, pencemaran air, pencemaran udara, pencemaran bunyi. You have studied this in geography, okay? So I don't want to repeat again. Okay, so anyway, let's move on to our exercise, shall we? Okay, let's go into our exercise. All right, so today I'll be focusing on the exercise because you know, there's nothing much else to say already. Okay, anyway, let's go to question 5. Okay, let's go to question 5. This is in page 12. I'll try to do as many questions as I can. So figure below shows the reaction between metal X and oxygen. So yay, metal X and oxygen, they are getting married. All right, they're getting married. Oxygen is marrying metal X. So can you see the reaction? Ooh, nice flame. I think we did this question last week. Okay. Oh, nice flame. So is metal X reactive towards oxygen? Is it reactive? Like I said, reactive is lang chai, good looking. Okay, good looking. So is metal X good looking? Is he a good looking guy? Hell yeah, he is. Okay, hell yeah, he is. So you can say yes. Okay, you can say yes because of metal X burns. Okay, or you can say even a better answer. You can say metal or you can, you know, I don't want to say metal X. You can say the reaction is vigorous. Okay, tindak balas yang cergas. What does it mean by vigorous? Vigorous means very happening, very passionate. Right? This good-looking guy and this girl getting married, wow, the love of fire, man. Hey, I told you this last week, right? Oh, sorry, wrong note. Okay, last week, right? Like I said, if you marry magnesium, wow, you see, magnesium is the 4th good-looking guy, the 4th best-looking guy. If a girl marries magnesium, she's very happy because you see, ooh, nice flame. Wow, the flame of love burns bright, very vigorous, very happening. And then on the other hand, if a girl marries iron, iron is like the middle guy. Okay? He's not too bad looking, but not too good either. So you see the reaction is like, okay, this is, ooh, the girl gets very excited because the husband is very like this one. The husband is like so so the reaction also so okay, I mean, like I said looks are important guys. Okay, I'm not trying to be shallow here, but looks are important. As I said, who doesn't like pretty stuff? Am I right? Okay, anyway, so B, metal Y. Okay, there's another metal Y now. Okay, this is X, right? Now we have another metal Y. So metal Y glows brightly when it reacts with oxygen. Now it only glows, you see? Only glowing. There's no burning. So is metal Y more or less reactive? Like I said, reactive is lang chai. So is metal Y more or less lang chai than X? Of course, metal Y is less because you see, sad. The girl is not very excited getting married to metal Y. Okay, sad story. So it is less reactive. So 2 marks here, they should ask why So why? Because metal Y is less lang chai than X. All right. Please don't say good looking. I already told you good looking means reactive. It's a better way to let you understand reactive. So Y kurang reactive daripada X. So Y is, you know, so okay, worse than X. That's why the mixture only glows. Right? There's no burning. And then C, if metal Z does not react with oxygen, so you see, Z is the worst. The girl doesn't even want to get married to Z because Z is too ugly. Z is most likely gold. Oh, I keep opening the wrong note. Okay, Z is most likely gold. Z, very bad looking, very ugly. So of course you wouldn't want to get married to him lah. So metal Z does not react with oxygen. So arrange them in a reactivity series based on their reaction. So who's the most reactive? The most reactive is of course X. Of course it burns brightly. And then the second reactive is Y. Of course Y is less. And then the third, the least reactive, the worst looking one, the ugliest guy is Z. So X, Y, Z. Okay, can you understand? Hey, guys, if you notice, maybe you haven't, but if you keep doing these questions, you will find that they most likely look the same. It's all about that good looking chart. The question is same over and over again. So that's why I said this chapter, it might seem very hard at first, but when you really go and study it, it's not that hard. All right. Hey, for God's sake, man, you only memorize one stuff for this chapter, which is that good looking chart. Compared to your chapter 1, those eyes lah, nose lah, ear lah. Let me ask you, even the eye alone, how many parts already? You have the sclera, choroid, retina, and then you have the aqueous humor, vitreous humor, the blind spot, yellow spot, lens, ciliary muscle, suspensory ligament, cornea. It's already more than this. Okay, and then you have the ear, you have plants. That is only one chapter, you know. So you see, this chapter is so much easier. I don't get students who say, and you know what's the funny part? Most students they get wrong. Most likely it's from this chapter 1. I don't understand. How can you get wrong with something so easy? All right. Anyway, so let's move on. Let's go to number 6. Let's go to number 6. So the diagram below shows the apparatus set up to study the reaction between magnesium and oxygen. Oh, now they're getting married. Like I said, you will most likely be doing this experiment in school. I think, I'm not sure lah. Most likely you will if your teacher is good enough to let y'all try. Diva, are you okay? Guys, my internet here is not very stable. Okay, I'll let you know first. Because I've been disconnecting just now for a few times already. So pardon me if this thing lags for a while. All right, and if it lags, I will repeat this again. Okay, so sometimes they will lag for a bit. All right, anyway, so this experiment you'll be doing in school. So what is this? When you burn magnesium here, magnesium will kawin with oxygen here. Magnesium will kawin with oxygen here, and you will see something like this. You see something like this. You see magnesium, oxygen, they burn very nicely. All right, so this is what the experiment is about. So why do we have one more thing here? Do you remember? I actually mentioned this last week. What's the function of this thing? Your potassium manganate 7. This thing is to give oxygen to this fella. So the job is to provide oxygen untuk membekalkan oxygen. So my job is to produce oxygen, give it to the magnesium. So now magnesium can kawin with the oxygen. Okay, and if you still remember, I told you this last week. Do not ever let this thing touch this thing. You will get a nice explosion. All right, you'll get a nice explosion. So don't do it. That's why we put a glass wool here. All right, I believe that's the next question. So what is the function of glass wool P? The function is to separate these two. Okay, so it is to separate your potassium manganate 7 and magnesium. I'm just lazy lah. I write PM7 instead of potassium manganate 7. I don't want to write so long. Right, so your BM is to asingkan your kalium manganat 7 dan magnesium. The job is to separate these two. All right, next, explain what will happen if glass wool Q is not in place. You might say, sir, why is there another glass wool here also? Why is there another glass wool? When you look at the experiment last week, no glass wool one. Why did it sound like one got one? This is to actually prevent your magnesium from shooting the sparks out from the test tube. right? Because like I told you, magnesium's reaction with oxygen is very vigorous. They produce this very nice big flame. And when you have flame, you will have sparks flying everywhere. So if you don't want that to happen, you put a glass wool here so that they don't just fly everywhere without reason. All right, so what's the point? If you don't put Q there, so you can say sparks might come out from the boiling tube. Okay, so percikan api akan keluar dari tabung uji. Tabung didih, sorry. Tabung didih. So you have sparks flying out, then you will create some sort of mess lah. So it will be a very messy experiment. Guys, this experiment itself is already very messy. Right? It's already very messy. So even if your teacher let you do this, she won't give you too much magnesium powder. She won't give you too much. If you naughty, go and put more. If your teacher say you can only use like 5 grams, if you naughty, go and put 10 grams here, you are going to blind everyone in your class. Like I told you, magnesium is very reactive and they produce a very bright spark when they react with oxygen. It's like your camera flash bright. So if you put 10 grams here, you're going to flash everyone blind in your classroom. So that's not a very good thing to do. All right, so anyway, D, write the word equation for magnesium and oxygen. So magnesium plus oxygen, you will get magnesium oxide. Like I said, when you get married to a guy, you need to change your name a little bit. It's just like I said, if you get married to Mr. Law, then you are Mrs. Law. Right? Okay, so this is how you change your name. So next, E. Now I repeat the experiment by replacing magnesium with aluminium, zinc, and iron. So now this is the table. So as you can see, magnesium, very vigorous. The flame is very big. And then aluminium is only big, vigorous. There's no very. So you see, aluminium is less good looking already, right? Aluminium is less length already. So the girl is not so excited now. And then when you look at iron, very slowly. And zinc, moderately means okay. Not so bad. So arrange this in the order of increasing reactivity. How do you arrange them? From the lowest to the highest. So who's the lowest? Who's the lowest? The lowest is the one with the least reaction. So it's actually your iron. You see, burn slowly. This is the worst looking guy, iron or ferrum in BM, followed by zinc, because zinc is moderate, followed by aluminium, because aluminium is vigorous, and then the last but not least, the most reactive one is magnesium. It's sangat cergas. So as you can see, even you memorize your good-looking chart is like this one. You see, Mesti, Other, Zaka, fantastic. Right? Of course, they won't put this thing in sequence for you lah, because it's giving you answer already. Okay, so next, number 2, explain your observation if gold powder is used. Wow, someone has money to burn gold powder. Awesome. So what is it going to happen? Do you see something when you burn gold? Like I said, gold is the most stable, it's the least good looking. Gold look like shit, okay? Because the girl wouldn't want to marry gold. Because gold is like the worst looking guy in your class. Would you want to marry the guy that looks the worst in your class? I know that's a very shallow way to say things, but of course you wouldn't. Okay, why would you marry someone that is not attractive? All right, so anyway, so what's the observation? You might say there's no reaction. Okay, no reaction. The other tindak balas. So why is it no reaction? Because gold is the least reactive. Okay, paling kurang reactive. Oops. So they are the worst looking lah. They're the worst looking lah. You wouldn't want to marry gold, would you? Right? Stop lying to me lah. Oh sir, but they have a heart of gold. They have nice personality. Like I said, no matter how good personality the person is, if their face look like they're gonna run over by a truck, you wouldn't even want to talk to them. Okay? I don't know whether you're like this, because I'm like this. Right? Alright. What's the word? Which word? Which word? Least, yes, it's least. Okay, least. Sorry. Bad handwriting. Okay, you wouldn't want to talk to someone that is not good looking. I know I sound very shallow, but that's the truth, isn't it? Okay, I only talk to attractive people. Oh God, I sound so shallow now, don't I? All right. Anyway, so moving on. Let's go to number 7. So the diagram below shows an experiment of reaction between carbon and metal oxide. Oh, this is the Rampas wife experiment already, because carbon is trying to get the oxygen away, but they didn't say what metal is this lah. Okay, they didn't say what metal is this. So they just say they mix them together, and then state your inference. Now what is inference? Inference actually means explain. State your explanation. Right, state your explanation if the metal oxide used is aluminium oxide. Oh, that's a good question. So if I put aluminium oxide here, oxygen is married to aluminium. Right, so who is better looking? Who is better looking? So mesti Ada, Zaka, fantastic. And if you still remember, there's a Zaka in between C and H, which is your maths tutor. Okay, so as you can see, aluminium is better looking than carbon. Okay, better looking than carbon. So if you are married to a better looking guy, would you leave your husband for an uglier guy? No, you wouldn't. No, you wouldn't. So there will be no reaction. You are not breaking up with your husband to go away with the uglier person. So there will be no reaction. Nothing will happen here. But they don't want your observation. They want why. Why is there no reaction? Because like I said, aluminium is more lengthized than carbon. So because aluminium is more lengthized, okay, lengthized means reactive lah. It's more lengthized than carbon. Right? So what about zinc oxide? Next one. What about zinc oxide? So you see, and now it's a different story. Okay, husbands having trust issue. Okay. I'm sorry to say this lah, but most they are like that. Hey, it goes for guys and girls though. All right. If your marriage is not happy, you will tend to leave the person for someone else. Not very common in our parents' era, but it's getting more and more common nowadays. This is why the rate of divorce is going up. Right? I mean, it's not surprising, okay? Anyway, so your zinc is here, carbon is here. So carbon is better looking, right? So when I put carbon here, ooh, carbon is better looking. So as a wife, you will say, screw my ugly husband, I'll follow you. Cruel slap to reality. Yeah, exactly. Guys, I'm a very realistic person. I stay real. Okay, if I will say it as it is. Right? Like I said, I don't talk to ugly people. Hey, do you know this? In a lot of society, this is actually a research. Attractive people tend to get higher salary than less attractive people. So are you saying that jobs are discriminating? No, they are not. It's just basic human instinct. You see someone more pretty, you will give them job instead of the ugly one. Right? Let's just talk about celebrity. Let's say some agencies they are hiring they want celebrities. Would you hire you if you're ugly? Why would they? Right? So it's a very cold hard truth. Right? This is why plastic surgery, correct, so high lah. Okay, would you leave her? I mean, I wouldn't lah. I wouldn't lah. Okay, because I think my wife is the hottest to me. All right. Anyway, so carbon will take away oxygen from zinc, right? Because carbon is more lengthy than zinc. Okay, so guys, never ever stop making yourself attractive. All right. Hey, let me tell you lah. If you are ugly, I mean, in a sense that you don't take care of yourself, you don't groom yourself, you don't keep yourself clean, you don't dress properly. If you become ugly by choice, even you wouldn't love yourself. Wow, real talk here, guys. Wow, you know what? I should be a motivational speaker. Damn. I don't want to teach science really. I go and do TED Talk already. Go and motivate people. Okay, so carbon is more reactive than zinc, so that's why carbon can take away the oxygen. So you can say carbon can reduce. Reduce is the Rampas wife. Carbon can reduce the zinc oxide. Right? Or whereas the up there just now, carbon cannot reduce aluminum oxide. Reduce means Rampas lah. Okay, reduce is Rampas wife lah. Okay, so anyway, let's finish this if we can. Based on your inferences, based on what you explained just now, conclude the position of carbon. So where is carbon? Carbon is lower than aluminum, but higher than zinc, right? Based on what we learned just now. So it is lower than aluminum, higher than zinc. Oh shoot, I forgot to write the BM just now. Lebih reactive and tidak dapat menurunkan. Okay, reduce is menurunkan. Okay, menurunkan. So in this case, you can say boleh menurunkan, and then this one is tidak boleh menurunkan. Because reduction is penurunan, right? So lebih rendah daripada aluminium, lebih tinggi daripada zinc. Right? I'll just say the BM here lah. I'm just too lazy to write. Okay, anyway, C. Predict what happens when a piece of burning magnesium ribbon is dropped in a gas jar filled with carbon dioxide. Okay, this is a very good question. So when you have carbon dioxide, you see now, oxygen is married to carbon, right? And then if I put magnesium here, so who's the better looking guy? Obviously, magnesium is better looking, right? Because magnesium is up there. Okay, because mesti ada Zaka. So C is here. So magnesium is higher. So what will happen? So mixture glows. Okay, campuran membara. When something is glowing, you know there's a reaction. The wife is changing husband. Then there's the glowing. If there's nothing, you don't see anything like this thing in this case here. You don't see anything. There's no changing husband or wife. You just stay as they are. Okay, so the mixture glow. Why? Because magnesium, Rampas wife is reduced. Magnesium reduces carbon dioxide. Why? Because magnesium is more lengthy than carbon. Okay, magnesium is better looking than carbon. Can we like pop sound? No, there's no pop sound. There will be no pop sound. Pop sound is hydrogen only. Okay, it will be glowing. You will see fire. You will see flame. You will see somewhere lighting up and fire. Things like that, right? You won't hear anything. Okay, can So you know what? I think I'm going to stop here today. As for the remaining questions, next week we will most likely be entering the new chapter, which is chapter 5. But I will try to spend a little bit more time here first. I'll try to finish the exercise here first before we move on to chapter 5. All right, because this chapter is rather important. I will maybe finish the question, so make sure you understand better. Okay, so anyway, thanks for coming, guys. I hope you learned something new today. Not really something new, like from last week. Okay, so I wish you have a happy Thursday night. I will see you again same time next week. All right, so good night, everyone. I'll see you soon. Take care. Bye-bye.